Eaton Corporation, we serve as a power management company. We're in your cars, we're in our planes, we're in the walls, we make the lights turn on, we distribute the power from the grid to your homes, to your businesses.
Eaton's products really touch all sorts of different kinds of power management systems. We have a really wide reach because of that common thread of power. What are some of the challenges that are surrounding doing manufacturing at a global scale? Well, Eaton has many different locations, plants working in all these different kinds of product spaces, supply chain, on-time delivery, making sure that we have the quality that we need for our products is always really important. It's a really complex ecosystem to actually get parts produced and out to our customers. Our Additive Manufacturing Center of Excellence is one piece in that, where we're here to help support some of the issues that can come up within our manufacturing plants.
Eaton is a really exciting place for additive because we have such a diverse manufacturing footprint and such a diverse product portfolio. We came up with a portfolio of standards across all the different modalities that our sites can adopt and choose to invest and grow with. And what we're really looking for there is ease of use, reliability, and repeatability. Because when we need to print something for a factory, we need it now. We've been working with Formlabs for a lot of years now. We have a lot of experience with the systems. We know that we can rely on those. We know that they're going to work when we need them to work and produce what we need to do. So what we need to be able to provide to our internal Eaton sites is options in the SLA and SLS categories. As each site and each group is looking to mature in their additive journey, they're looking to explore into new spaces, into new materials. We think that SLS and the SLA platforms will really help them to grow and to continue to push the envelope in their additive adoption. One of the first rules of thumbs for SLA is when we're looking at really tight tolerances. So if I'm engaging with a factory that says we need sub-micron level accuracy, really good surface finish, high repeatability on fixtures or tools, that immediately often triggers I think we might be talking about SLA here. The other one is around some materials. SLA can provide some pretty unique material properties in terms of hardness of plastics or strength and rigidity, also temperature resistance. We're usually turning to SLS when we're talking about printing higher volumes of parts on a very regular basis. There's also times where nylon is just a really good logical material for an application. Anytime I walk into a factory and we're using Delrin for grippers, part locators, things on our automation line, that almost always triggers I think we might be talking about SLS here.
So at Olean, we have two facilities. One, we have a metal oxide barrister building where we make distribution class and station class discs. These discs end up into a lightning arrestor, whether they be distribution class or station class. Our end use customer would be a power utility company. Their end goal is to take a lightning strike to ground before it makes it to your home. A small disc like this is considered a distribution class. You would find these on a power line on your way home from work, whereas a disc like this would be a station class into a substation or outside of a large mall or airport, protecting that equipment. The typical volume that we would see here is about 15,000 parts a day. In order to make that happen, we use a single piece flow where there's a lot of automation involved to move our parts. We use a lot of nylon in these end-of-arm tooling, robots, fixtures, things like that. Robots tend to be pretty generalized. They become more personalized when it reaches your product. Additive manufacturing has helped us bridge that connection with our product to the robots to have more personalized tooling for every individual product. We had proven our use case with our FDM printers, but we were trying to source something that was good at printing nylon. Nylon's kind of tricky on FDM. We reached out to the COE, and Cam Peel actually made a couple SLS part examples for us. Management was willing to take a chance on what we could do with the fuse. We estimated about a 9-month ROI, and we ended up getting that ROI in about 6. We've had a couple use cases of urethane overmolded products that we utilize in coolant-rich environment. We swapped it out with an SLS and FDM combination. The two parts really complement one another for their individual material attributes. We consider production consumables to be a part that is doing work on our product, whether it be centering it up on a conveyor belt, picking it up and moving it, doing something holding the part. Because we have so much product going through, they tend to wear out. That's where the SLS comes in handy. I'm willing to wager that 90% of what we had of machine nylon production consumables are now SLS. What we like about the Fuse is that it is an accessible product. There's other equipment out there that's $250,000. It's a tougher sell when it comes to capital time. The Fuse is an industrial machine at a more affordable price. As of late, additive manufacturing seems to be the simpler solution to a lot of our problems. Like, well, we'll just 3D print it.